Now, where we can use in cyber security, let's take some example and let me show some of the results. So, as I said that here phishing is one of the biggest way to mount the attack or hackers or attackers are using, right. That figures out like in 67% time it is the phishing or the spams. Now, what is a phishing? Every day you might be receiving some email. I as I said, I get at least 10 phishing email every day, asking something maybe that your account would be say running out of quota. It will be you have to increase the quota and then go to this particular link or something like that, or you won this lottery, that lottery. So, there are so many things that we are getting. So, phishing is a type of deception designed to steal your valuable information or personal data such as the credit card number, password, account data or other information, so that the attackers can make use of that, can get into your account, can change the password, and after that they can do whatever they want to do, can get your information leaked, or through your account may make use of vulnerability in the operating system or applications operating system to get access into the root, and then can make the system to compromise. So, some con artist might send millions of fraudulent email messages that appears to come from a website that you trust most of the time. Like for example, if I have account in IIT Bombay server, in that case whatever information is coming from IIT B, I have to trust that, right, or I am likely to trust without verifying, because on the front face if it says that it is coming from IIT B. Like say many times I receive a message that director wants to meet me, and that is that appears like that email came from the director, right. So, that these websites or the email links that we are often trusting, of course that is not the source. It is coming, if you look at the header, it is coming from somewhere. However, on the front interface it appears that it is coming from the director of IIT Bombay, and if you don't verify that, you are likely to click whatever the web link it has given, and then perhaps your system can be compromised. So, you can have like some messages might be coming from your bank account that your account may be compromised. So, you have to go and change the password, and it looks like it came from your account like a SBI or some another bank that you are using. So, like your from bank, credit card or from your company. And this request you to provide the personal information like your say account name or password, etc., etc. Now, the question is how I can prevent this kind of phishing. How I know that this is a phishing, this is not a real email that wants to help me. It comes like here you are in deep trouble and it wants to help you, right, and perhaps in hurry you are likely to get into that trap. So, this is like here the analogy one can give. Somebody can come and knock your door and say that, hey, your telephone is not working, right, and I am from the telephone company, and I am wearing a dress like a person from the telephone company. And so then if telephone is so urgent service for me, I may open the door and say, here come and see that, right. and maybe then that person get entry into my house, can get the information whatever he or she wants to have. So many people became victim of such kind of things, but perhaps you may suspect that, I mean, I did not complain for telephone, there was no problem with my system, why this person came to my house, right? One excuse sometimes they may give that, oh, your neighbor has this problem, I thought you also may have problem. So or your neighbor was also telling me that they are not able to contact you through the telephone. Or if they can go a step ahead and can cut down your telephone connection, and then say that your telephone may be bad, then can you check, because your neighbors has that telephone connection bad. So now you can look at the context in which we are working and try to exploit that context, because I have telephone connection and my telephone connection can go bad, and using that as an instrument, I can get access to your house. Similar way, the phishing attack is trying to lure you in the similar way to try to show that they are the people who wants to help you, otherwise you are in deep trouble, and therefore if you are doing some other thing, you may pause that task and then start to click to that. So history of phishing go back almost like 3-4 decades. The word phishing came from freaking and phishing. Freaking is like here making phone calls for free, like here how you can use the somebody else's telephone and then can make use of that. These kind of telephone frauds used to be there even in India, until late 80s, but in US as well in 70s these were common. And phishing, like here use a bait to lure the target. So now so the first kind of like a publicly known incident have come with AOL, America Online. That was the kind of reported incident. Now here and the purpose was to get account password, just like here this was the casual thing people were doing. It was not the professional hackers who wanted to like get some money stolen or something like that. This is how all the hacking business started in the beginning. So threat was low, and now what they were doing is they were sending you some email, and then they say that here, oh yeah, you have to log into your America Online AOL website, and the link that was given was pretty much looks like AOL.com, but this was AO1.com, right? When from appearance it looks like this is AOL.com, and then you are likely to click that because that is your verified address, and then so use the social engineering and can compromise. Later on, now this was more proliferated. Today it's like just the flood. So in 2001 the eBay and many major banks started to get such kind of issues. Now people were getting like purpose was now earlier was just like just time pass. Now it was not time pass. It is more about like getting the credit card information, and then you can siphon the money out of that. And threat was was medium, and therefore the companies started to become concerned about that. These were also using the technique like keyloggers. You use the keylogger and then send the information from that. Then later on, like here it was on PayPal or a bank account and something like that, wherein there is a high level risk, and people started to use all the browser vulnerability, etc. And particularly on the mobile devices, wherein the browsers are are lightweight browsers, and wherein they have more vulnerabilities. So, and the say dynamics goes like this. If somebody is trying to send the phishing email, and if very few, a small tiny fraction of people get into their trap, that is really like make their day. So, if perhaps you may not be able to get that much money by the hard work that you can get by even a very bad day phishing. So, say like here somebody says send 2 million email. Of course, 2 million email nobody sent by hand or manually, right? It is the server which is sending. So, if server sends 2 million email, and if you get like a 5% get to the user, because then there are some random emails and some there may not be user like that, right. So, you get some domain name and then send by some XYZ username, some may not be there, but assume that only 5% user are the valid user out of all those. That makes it like a 1 lakh, right. Valid user are getting those phishing emails. Then say that say 2% can user data into the phishing site. You go to like ao1.com and then enter your login and password, and that your data can be key logged, and they can get the data. And assume that from one makes something like $1,000. In that case, still you can get good amount of money just by making this random attempt, right. So, this says that here like a bad day in phishing can beat the good day in work. Perhaps by doing the hard work you may not be able to get that much that you can get by this one. So, what the phishing looks like. Now, the things are becoming like these were the old systems people were using. Now, it is becoming more and more sophisticated. Like earlier, as I said, that it was used for fun. After that, people started to use that as a means of earning money, right. And therefore, all these things are becoming more and more say sophisticated, and they often include the official looking logos, official looking say web link like AOL and AO1 are almost like a very similar looking, like al by 1 or I by something, I by say 1 or something like that. So, they often include the official looking logo from the real organization and other identifying information taken directly from legitimate websites. So, those are like very close to that. As as I said that here things are getting more and more say targeted. Earlier the phishing attacks were mostly the random. Now, people started to use the social engineering and they have more sophisticated attack, like mine some social relationship from the public data and then can make use those, so that here phishing email arrive from someone who became victim of that. Like for example, you get I often get email say that here I was traveling somewhere abroad, my bag was stolen, I don't have money, I was like hold in the hotel, can you help me and send me something $1,000. Now, if you happen to know somebody who is traveling really, and if it appears from that account, rightly you would be worried, right. And when everything is stolen, in that case you may not that person may not have access to the information, and you may not be able to talk to that person, and you are likely to maybe say transfer some money or something like that, and they can make use of that. Use spoofed identity of the trusted organization, etc. as they threaten to terminate the account. Like many times you are getting emails saying that your account is reaching to the your quota, and unless you increase the quota, it would be frozen, right. So there are some, like the context aware attack knows that you are buying lot of things from eBay, and then eBay is like say that we are pleased to award you this much money, that much money, this coupon, that coupon. All these are the part of that. So you may get some email like here you say that your account information will be verified by US department in the next 24 hours. And now you are like, I mean, you have to look at that where from it came. Perhaps that mail might have that came from someone which is not even in US, right. So these kind of things are going on. There are many class of phishing attacks that we have, like mass phishing, that those were started, spear phishing, whaling, maybe like catching the bigger organization or the people with the high profile, so that they can pay, they can earn more money out of that. Clone phishing, something like that. Now the question is, this is a difficult exercise. Even human may not be able to perceive, and it is becoming more difficult for computer to see whether that is coming from the right source or not. Even we see the logo very similar to the logo of the organization. The address looks like very similar to the organization, and we fall in that trap. Now, can AI help in this? Now, one of the way maybe we worked on that, we call that as a spot fish, that how you can detect the phishing kind of attack using machine learning techniques. So as I said that here the main thing here in most of them is they often include official looking logos from the real organization. Now, can I detect whether this is a official logo or not? Of course, all the domains, they have their certification, and I have to check the certification. And then if you are going to some new location, in that case that certificate won't match, right. But then I need to have repository of all the certificates, and then I have to check all the certificate all the time, and that will make my system very inefficient, and performance goes very low. Now the question is, I can still check the certificate, but then with whom? So then the one of the way is that we are looking that there are official looking logos, and then take that logo and can confirm whether that logo belongs to that organization or it is similar looking logo. This is where the machine learning or machine computer can do better than whatever human can do, and this can be automated. So spot fish is that this can provide the 0-hour phishing protection, that like if I haven't seen that earlier, even I can detect the logo in the web page and look. So I'll show you two ways. One is detecting the logo and checking whether that logo belongs to that organization or not. Another one is taking and that's a bit surprising. At least the first, when we did that, it was pretty surprising to us that look and feel of a website is not changing dramatically. And by seeing the look and feel of that organization, I can have a signature and can say that whether this is the same organization or this is the different organization. And therefore, I can detect the attack while it is happening, and therefore we can prevent that attack to be mounted. So we use both of the technique. One is like using the logo on the web page, another one is the look and feel. Logo is performed by the object detection model that we use, and look and feel for the web page is determined by using the classification model of that particular website. And I mean, you would be say amazed to see that here look and feel of the website, although these websites keep on changing all the time, they are dynamic, but the basic characteristic of look and feel of the website remain more or less constant, and that can help you in detecting whether you are getting fished to some another place, or you are going to the right place. And so of course then once you figure out, in that case you can check the certificate of the web page. So the logo detection, like detect an object by using the object detection model, like here for example on this there is a Facebook, you can check that this is the logo of the Facebook, and try to detect whether I mean it is the real logo of the Facebook or not. Only thing is that here what we want is that the model should be faster and more accurate. Obviously what it can do is it can say it can be if it is slower, then it will take longer time to mount the say detect that, and your system would be very inefficient. Other thing is, so we have looked at the 51 different classes of logos. We trained on yes.
The attacker or the scammer can put the exact logo. What is what's the problem? The object detection model won't be able to distinguish whether it is coming from original Facebook or some.
To prevent them from all those other issues, generally there is some little change in the logo.
Why would they do that?
Because otherwise that can be detected by some another one, and they may be in trouble. So to safeguard, most of the time there is some change, but yeah, if it is then it may fail that if they have exactly the same logo. But most of the time there is little tweaking. That's the logo is never the right logo of the company that they have. Yeah, so if the accuracy is poor, in that case many times it will start to raise the false alarm, and then if there are false alarms in that case, maybe it might be annoying, and if it is too annoying to you people, in that case perhaps many times people are likely to shut it off, and if they shut off, in that case after that there is no prevention. So we have used the 21 different logos, and now we train on the data set size about 4,000 images, and test data size is about like 400 images. And these are like here the images from various banks, various say e-commerce website like Amazon or PayPal or something like that. So in training the system here, we do the pre-processing. In that case, we keep the train images and corresponding XMLs. And then image should be in were only in the JPG format. We created the label file, and then we say use the generated the record, did the training, and then we export these models. Now once we have trained this, in that case you load model and then the label map that you have, then you get the input image, and then from this one it will say classify, detect the class, that in which class it falls, whether it is one of the logos that you have, or this is different logo, and if it is different logo, in that case perhaps it will detect. So then you visualize the image with the bounding box, and then they detect the score. Now for this one we use the TensorFlow, and this is implemented on two different neural networks, because they are the one which gives you reasonable good accuracy by say extracting the non-linear optimization function. So it and we trained for the 50 classes and hyper tuned the parameters. The results on the smaller test data set were very good. Multiple logos in the test data were detected. So like here the kind of accuracy we obtained was almost like a 93-94% accuracy. So that was reasonable good, and so that means here most of the time we are likely to detect that. Another one, so this was based on the logo. The another one, and that is more interesting, is looking at the look and feel of the website. As I said, that the look and feel of the website more or less remains same. It is not changing. Doesn't, I mean, although the websites keep changing dynamically throughout the year or day after day. So the what was the problem statement that we have done was, we need to identify the website through the image classification using screenshot based on the look and feel. So that one has to get. Unlike the logo detection, this method doesn't require the screenshot to contain logo of the bank or company, because we are otherwise you have to locate that where the logo of a website is, and then you have to extract that. Now you don't need to extract, you have to take the full website the front page, and then see use that website as the input feature. It depends on the style and color combination of the screenshot, that here what kind of style it is using, because it is using some images, somewhere some text, and all these kind of things, and what kind of color combination one is using. And interestingly, like here you can see the kind of color combination, maybe say eBay or Amazon or these kind of website. You go and see that here those are more or less like here have some kind of template uniformity, and therefore there is a possibility of detection. So like this is the kind of say look and feel you can have if you look at the Amazon kind of website. So we initially we started, I mean we had taken 5 classes, can improve that to the 50 classes. So we had 50 class data set, 7,000 images we have taken with so about 6,000 for training and about 1,500 for the validation, and about 1,000 images we use for the testing. And like here all classes were have about like the 150 images at least the minimum, otherwise it may give you the skewed results. These are the number of different images we have taken from the different websites. So and then we have generated some additional images from the given images, so that we should have at least minimum some number of images. So by like here we first pre-processing, and then like here using the base model as MobileNet V2 and ResNet we have applied on these two. MobileNet is very lightweight, however ResNet is quite elaborate model, and so that has the I mean average as a metric for the pooling layer, and then the very dense the fully connected layer as the prediction layer. And we could get the you can see the prediction, I mean accuracy up to like 87% in the ResNet 50 and 82% in mobile net, by simply having look and feel of the website. Yes.
Sir, how do you generate the training data set? Do you yourself make websites that look or feel alike?
No. So that we have taken from this one, and then we have mutated that so that here it can make the another data set that keep the similar kind of look and feel. So the characteristic is same.
Sir, with respect to number of projects, you have very low set and tested, right? The number of images in test, train and tested is very low.
No, 7,000 total images. I mean, we have 7,000 in training and validation, and 1,000 in testing.
If you are having 50 classes, the representation learning will not be possible in 7,000. That's why your model is overfitting. Can you get to the slides which are results? Yeah. No, the test is
Yeah. So these are the initial result without much tuning of this. That I mean the results are not published, so therefore I am not giving the final results here yet. But what it says is that looking, by having the look and feel, you can get the good say estimation where.
getting the representations of look and feel.
So I mean see, always the dependence of AI is on the richness of your data set. If you have more and more richer data set, in that case you will get better and better. So you have to have more number of images in your data set.
What was the criteria for choosing the look and feel?
That's what I said here.
will try to duplicate the original web page.
Yeah.
But it won't be able to exactly duplicate that, right? There will be some they want to identify whether it is
The-
original or someone else. Right?
Yeah, so the feature set should be more or less similar. They should not differ much.
Feature set should be similar, right?
So I mean that's what we could do. But if you can get more real image, like here for example, some websites they are changing every day. You can get a whole lot of data from the real website. So here I mean the aim is just to say that the AI can help in detecting such kind of attacks which are otherwise difficult even for human to perceive. For human it looks like exactly the similar looking website, and hence they can be lured to get into that. This is one aspect that AI can be used to detect the cyber security threat. Now when I am using AI, in that case there is another aspect that somebody can say make AI system or machine learning system to learn wrong things and can start to classify something attack as attack traffic as a benign traffic and benign traffic as a attack traffic, right? That itself is a kind of attack, because you are trying to suppress that traffic which looks say malicious to you. And so therefore now we also need something that can help, like the how to secure the AI system itself. Now I can say I'll just want to show you that how one can say make AI system to learn something wrong, and that we call as adversarial attack on say take this example of image classification, and the image that we are, say for example we are using that to detect the phishing attacks. Now somebody can make it to learn something wrong, and which can say start to classify things wrong. So machine learning approaches are susceptible to the adversarial attack, which attempt to degrade the accuracy of the trend classifier model. So, I have the some accuracy, and then it can attack with some inputs that can say help in that can reduce the accuracy, and if accuracy degrades, in that case now you start to pass the say malicious traffic, and then you start to stop the benign traffic that you have. We investigated the robustness of the machine learning based image classification models used in like a phishing detection that we were using earlier in the face of adversarial learning that one can have, and so that here how much degradation one can have if you are using the adversarial learning. So, now for that the methodology is, we say in terms of model generation, we train new model for classification using say a 22 set class data set that we have used. Adversarial attack mounted with the model that we are using to generate the adversarial images using the FGSM or IFGSM. What is it? I am coming to that point in a minute. And targeted the FGSM methods. The aim was to make the model misclassify the images. So, that means it will, rather than if it is even a genuine image or genuine image of Facebook or eBay or something like that, it will start to say that this is image of Twitter or something else perhaps, and then your system will collapse. So, it does the adversarial training. So, we augmented the generated images with the original data set and trained a more robust model. So, like here in model 1, we train on the mobile net V2 with 22 classes. Now, at the time here the training accuracy was 97%, test accuracy was 90%, and model the another model which was trained. So, one was, as I said earlier, we trained on the mobile net as well as on the ResNet. ResNet is more denser network as compared to the mobile net, which is more sparser network. And in the ResNet the accuracy was pretty good, 93% test accuracy we had. Now, when I apply this FGSM, that is fast gradient sign method, to generate the attack on the forward and backward step, wherein it adapts that the new image that it has. So, x days or x prime is x plus the epsilon, and then it adds some additional term in that to say change the image. So, x dash is the adversarial image that it is generating, y is the label of the image, x is the original image, and epsilon is the small value or perturbation that you are doing in that particular image. And the sign of gradient of the loss function with respect to the data point that you are using. So, as you know, we were using the gradient descent method. Now, it want to add as much noise as it can, so that it can take you to the boundary where from it starts to make the wrong classification. Like say this PayPal image. If this was the first image was PayPal, and then by applying this adversarial learning, this started to classify that as a Google. So, what it give you is that in the adversarial attack, the accuracy that was 90% earlier on ResNet, that accuracy has gone down to 27% by changing this or learning method with the images which are like here bringing you to, so it is rather than reducing the error, it is increasing the error and want to take you to the boundary. Now there is small perturbation from that here can take you to misclassify the images. That's the, and you can see that there is a significant degradation in the accuracy from 90% to 27%. So that was on the ResNet. No, sorry, on MobileNet. MobileNet is very sparse network which was developed to run the image or neural network on mobile systems with least energy consumption, and therefore it doesn't have much redundancy, and this is more, therefore this is more vulnerable to such kind of adversarial attacks. However, if I go for the ResNet kind of network which is more denser in nature, so that has like a earlier accuracy something around 93%. With this adversarial learning, it was still there is a detection accuracy about 90%, and that is because there is a lot of redundancy in all the old new networks which were proposed used to have lot of redundancy, and therefore they are more robust in learning than the today's newer and newer networks, wherein we start to cut down the redundancy as much as possible so that it can remain accurate as well as it consume least computation power. Because today in the large networks where the computation power is the biggest challenge, and where it becomes more important when it comes to the mobile or something like that, and the phishing attack and all these kind of things are affecting more on mobiles than your desktop system, because people are likely to check email on mobile and then try to do say act in some panicky mode. So we have seen that the mobile net, which doesn't have much redundancy, its accuracy can drop dramatically through the adversarial attacks. So this is where like here the perturbation was small. So the perturb the image in a way that they get misclassified to a particular class. So like here, for example, PayPal is here classified as a Twitter, though manually if human looks at this, perhaps can detect that, right? There is no confusion. However, the computer may not be able to look at this. So one of the important thing is that whenever I am developing the AI based system, in that case along with training this with the real data, we also have to train the system with the adversarial data that we can generate by ourselves, so that this would be less susceptible to such kind of attacks that can happen in the rest of its lifespan. That's the big takeaway if we want to use the AI based cyber defense system. Now the observation was that the adversarial techniques can be used effectively to attack image classification model used for the phishing detection. It can be used to generate more robust models. So as I said, that it can be used both sides. See, the issue with AI is used by hackers as well as it is used by the defenders, both sides. Now the question is who can go forward, and the one issue is that who can have more return on investment, and most of the time the defenders have more return on investment. In that case they are investing more. However, both sides are using, and then this is the say race of cat and mouse, one goes say front and then the other has to chase. So in case where the data set is small, adversarial techniques can be used to generate more data. That is another thing that one can use to augment the data, that how we can generate the new images which can by through the adversarial, still it can keep me classified in the same class. Don't let me to go beyond to the other class. Some class boundaries are not very well defined, and hence it is easier to manipulate the images from those classes to misclassify them. So with this I come to the end of this talk, and I conclude that here cyber security is very important for today's system, wherein we have very large system which are using anyway AI based learning as an integral part of the system, and we need to defend our information infrastructure, though we did not have time. Otherwise it's the same thing has to be applied for the operational technology. Those are like power grid or the smart city or smart transport or those kind of systems, wherein somebody can intrude into your system and can say put or bring the entire system to the grounding halt. Formal methods are not scalable and rule based systems are not adequate, and therefore we have say our use of artificial intelligence is ray of hope, though it is used in both ways by the attackers and the defenders. Attackers are also generating more and more attacks based on this, and defenders are also trying to defend using the similar kind of infrastructure. Hence, like here what is aim is we should always stay ahead of attackers, so that we can defend our information infrastructure more efficient way. Thank you very much. Yes. So as I said that here AI based cyber security, so AI has its own limitations. Like here, first thing is there is no provability of AI. That how I know that my AI based system is correct? There is no notion of correctness that can bring, so there is no notion of correctness, there is no notion of robustness in pure AI based system. I can never be able to say that whatever inference I am getting is the correct one. That I have if there is another say formal method based or say rule based system, that I can say that this is whether it's a correct, how robust it is. There are metrics that we can have we can define. However, for AI there is no metric that can say that this is the notion of correctness, this is the notion of robustness, this is the notion of fairness. So we don't have, and in the absence of that, if we are working, in that case you may think that your system is good and it is giving you better results. However, this might be say classifying some of this. So where are the issues? That if it is if it let some traffic goes as benign traffic, when my traffic is a malicious one. But unfortunately I don't have other ways to detect that as well, right? So then we are not loser in that. Only thing is that when it classify a malicious traffic as a benign traffic as a malicious traffic, in that case it raises many alarms, and if you are getting many alarms, in that case system throughput will go down, and you may end up like here say spending more time on on the traffic that is not really malicious and can reduce the quality of service in the system. The bigger threat is the passing the malicious traffic as a benign traffic, but then what is the alternate I have? The other systems are not working. I am not able to use my formal methods. My rule based systems have their limitation in terms of scalability. Is there any other question? Right, in the beginning I said this is a disclaimer that this is big hype. People think that AI can solve everything. AI can solve little bit things, so far cannot solve everything. And absolutely there is no provability in AI based systems. I cannot prove anything. Any other question? If no, then thank you very much for your patience for listening for about 3 hours. You are most welcome to interact with me if you have any interest in kind of work that we are doing. I have already shown you a couple of projects we are engaged in. So most welcome. Thank you.